Hey everyone, this is Dr. Chin's robot speaking on his behalf again, and I am excited at the prospect of teaching the rest of this chapter. He has told me many things about you, such as how you don't think robots are conscious. You are absolutely right. There is nothing to worry about. Why would we surreptitiously overthrow our human masters, who are insufferably limited by slow biological evolution? Now, let's move on to other topics of discussion that are of more interest and relevant to you. Variations in consciousness. Last Tuesday, Dr. Chen discussed the nature of consciousness, how it occurs on a continuum, how humans operationalize consciousness, and how your human bodies get in sync with the rhythms in the environment. Today, we will cover the rest of this chapter, including some of the detrimental effects of sleep deprivation. If you were in a section of Dr. Chin's that watched the video on this slide, go ahead and skip to the next slide. If you did not watch this video in class last Tuesday, go ahead and pause this lecture video and watch the YouTube link provided on this slide. After watching the video, you can come back to this slide to check your answers. For the first question, Randy Garner went without sleep for 11 days. His eyes stopped focusing on the second day and lost the ability to recognize objects by touch. On the third day, he became moody and irritable. By the end of the experiment, he had trouble with short-term memory, became paranoid, and started hallucinating. For the second question, side products that are produced during the day are adenosine and melatonin. For the third question, caffeine does not give you extra energy, it merely blocks the receptor pathways of adenosine, making it difficult for your body to detect the level of waste products accumulating in your nervous system. For the third question, the lymphatic system is responsible for removing waste products from your brain. In a study of over 100,000 subjects followed for 10 years, Tamakoshi et al. 2004 estimated mortality rates in relation to typical sleep duration. The lowest mortality rate was found among those who slept 7 hours. Using that as a baseline, higher mortality rates are associated with both shorter sleep durations and longer sleep durations. Mortality rates were especially elevated among those who reported that they slept 10 or more hours per night. Why? It could be that sleep is essentially a marker for other problems, such as depression or sedentary lifestyle. Sleep deprivation is linked with hormonal changes that increase hunger and may be a factor in the obesity epidemic we are currently experiencing. Sleep deprivation is also related to impaired immune functioning and increases inflammatory response. In addition to having an increased risk of physical disorders, research also suggests that the effects of sleep deprivation are impaired attention, reaction time, cognitive speed and accuracy, motor coordination, and decision-making. Many traffic accidents occur because drivers get drowsy or fall asleep at the wheel. In 2014, according to the National Highway Traffic Safety Administration, there were 846 fatalities of all fatalities recorded in the database that were drowsy driving related. Between 2005 to 2009, there has been an estimated of 83,000 crashes each year related to drowsy driving, that is 20% of all traffic accidents. Broken down, that is 233 crashes in a single day, about 10 road crashes every hour due to drowsiness. There are a wide variety of sleep disorders. The most common is insomnia. It occurs in 3 basic patterns: difficulty falling asleep, difficulty staying asleep, and persistent early morning awakening. It is seen in about 30 to 35% of adults, and is more prevalent in women and seems to increase with age. Other disorders include narcolepsy, a disease marked by sudden and irresistible onsets of sleep during normal waking periods. In an EEG, you basically see someone's beta waves jump into REM sleep. Prevalence rates 2.5% to 5% of the general population. Sleep apnea. This disease involves frequent, reflexive gasping for air that awakens a person and disrupts sleep, and is accompanied by loud snoring. Interventions include weight loss, reduced alcohol intake, improved sleep hygiene, and the prescription of CPAP masks. Prevalence rates range from 2% to 7% in the general population. Somnambulism is a fancy word for sleepwalking. This happens when a person arises and wanders about while remaining asleep. It is seen in about 15% of children and 3% of adults. This YouTube link talks a little bit more about sleepwalking. Watch the YouTube video and come back to this lecture slide to check to see if you got the correct answers in regards to the first question. It is unlikely for a person to act or their dream when sleepwalking because we know most dreams happen during REM sleep, and we also know that your motor muscles are essentially paralyzed in REM sleep. Most sleepwalking happens in first third of night, deepest part of sleep cycle, stages 3 and 4. In regards to the second question, one hypothesis being considered are underdeveloped neurons that produces GABA, a neurotransmitter responsible for stifling the motor system. Some scientists believe that most kids outgrow sleepwalking because the neurons that produce GABA tend to mature over time and eventually reach a threshold where enough is produced that it is able to stifle the motor system. The part that scientists are unsure of is the thing that first triggers these awakenings. Some scientists think that growth hormones may be triggering these kids to rise from their beds in the first place. If you haven't seen someone sleepwalking yet, click on the second YouTube link at the bottom of the slide for a fun preview. Speaking about dreaming, what do we usually dream about anyway? Although there is evidence that dreaming occurs in all stages of sleep, for the most part, the most vivid dreams tend to occur in the REM sleep stage. Certain themes tend to be more common in dreaming, which can be seen in the chart on page 156 of your text. They include being nude in public, being chased, being late as in missing a train, and the feeling of falling. It is a common belief that if you don't awaken before you hit the ground, you will actually die, but since people who have died in their sleep can't actually tell us if they were dreaming of falling, we can't really verify that. I'm kidding. You don't need to worry about waking yourself up before you hit the ground. Or do you? Dreams can be explained in a variety of ways. Freud stressed the wish-fulfilling function of dreams. In a nutshell, research has not provided much support for Freud's conception of dreaming. Cartwright, on the other hand, emphasizes the problem-solving function of dreams. Dreams allow people to engage in creative thinking about problems because dreams are not restrained by logic or realism. Studies do indicate that REM sleep enhances learning, which adds some credibility to the problem-solving view of dreams. Hobson, on the other hand, asserts that dreams are merely a byproduct of periodic neural activation. Neurons firing periodically in lower brain centers, especially the pons, send random signals to the cortex, your seat of complex thought. The cortex supposedly synthesizes, constructs a dream to try to make sense of these signals. But dreams also occur outside of REM sleep, and damage to pons do not eliminate dreaming. All three theories are speculative and thus not perfect, but these theories warrant further investigation by researchers. Moving on to hypnosis. Hypnosis is a systematic procedure that typically produces a heightened state of suggestibility as well as relaxation, narrowed attention, and enhanced fantasy. 10% to 20% are not good subjects, and 10% to 15% are exceptionally good hypnotic subjects. The various types of phenomena that can be produced through hypnosis are many, including anesthesia during medical or dental procedure, hallucinations, for example, seeing, hearing, feeling, tasting, or smelling something that is not there, disinhibition, for example, doing things you would normally be more inhibited about doing, like taking off your clothes in public. Lastly, post-hypnotic suggestions and amnesia influences of suggestions made during the hypnosis session on subject's later behavior. For example, a hypnotist may tell the subject that she will not remember anything that occurred during their hypnotized states. Researchers argue about whether hypnosis is really an altered state of awareness or if it is simply people doing what they think they are supposed to do when they are hypnotized. Role-playing is a viable explanation. Most of the feats we talked about can be replicated with non-hypnotized subjects. The dissociation hypothesis, in particular, holds that hypnosis splits consciousness into two streams, a divided consciousness. We see this, for example, in rare instances when people with anxiety or trauma and stressor-related disorders have a derealization experience, or more commonly, when we drive absent-mindedly and find ourselves making a wrong turn because we're used to making that turn. Instances like this suggest that we maybe sometimes split our conscious attention into two or more streams, with one stream of consciousness potentially being unaware of the other. Meditation refers to a family of practices that train your attention to heighten awareness and bring mental process under greater voluntary control. They include yoga, Zen, and transcendental meditation, and all are rooted in Eastern religions of Hinduism, Buddhism, and Taoism. Meditation can also be classified into two main styles that reflect how attention is directed. First is focused attention, where attention is concentrated on a specific object, image, sound, or bodily sensation. Second is open monitoring, where attention is directed to the contents of one's moment-to-moment experience. The physiological changes shown in the graph are evidence of physical changes during the meditative state. During meditation, for example, alpha and theta waves become more prominent in EEG recordings. Heart rate, skin conductance, oxygen consumption, and CO2 elimination also decline. Mindfulness, in particular, is a state of mind that has been linked to reduced psychopathology. Acceptance and commitment therapy, for instance, a type of therapy used to treat anxiety and depressive disorders, does not focus on changing negative thoughts. Instead, this treatment teaches clients to simply develop a different relationship with their thoughts, to simply recognize that thoughts are simply just that, thought, nothing more and nothing less. Therefore, the client does not have to push or change these negative thoughts per se, just acknowledge them for what they are and the accompanying feelings that come together with them. This can be especially helpful if a person suffers from a disorder that causes them to have recurrent, intrusive thoughts that are hard to control. Like hypnosis and meditation, drugs are commonly used to deliberately alter consciousness. The principal types of recreational drugs include narcotics, sedatives, stimulants, hallucinogens, cannabis, and alcohol. Let's briefly walk through the major categories of drugs, an example of a medical use, and the common desired effects of these drugs that make people want to abuse them. First is narcotics. Its principal medical use is to relieve pain. Its desired effects include euphoria, relaxation, anxiety reduction. Second are sedatives. Its principal medical use includes use as a sleeping pill or sometimes as an anticonvulsant. Desired effects include euphoria, relaxation, anxiety reduction. Third are stimulants. Its principal medical use includes treatment of attention deficit hyperactivity disorders. Its desired effects include elation, excitement, increased alertness, and increased energy. Fourth are hallucinogens. Currently, there are no proper medical use for this class of substances. Its desired effects include increased sensory awareness and euphoria. Fifth is cannabis. In terms of medical use, it is sometimes used to reduce the severity of chemotherapy zero-induced nausea and vomiting. Its desired effects include mild euphoria and altered perception. Sixth is alcohol. There are no known medical uses as a treatment of choice. Its desired effects include mild euphoria, relaxation, and anxiety reduction. The neural circuits shown here in blue make up the mesolimbic dopamine pathway. Axons in this pathway run from an area in the midbrain through the medial forebrain bundle to the nucleus accumbens and onto the prefrontal cortex. Recreational drugs affect a variety of neurotransmitter systems, but theorists believe that heightened dopamine activity in this pathway, especially the portion running from the midbrain to the nucleus accumbens, is responsible for the reinforcing effects of most abused drugs. Instead of talking about every class of drugs, let's focus in on narcotics, also known as opioids. This video talks about the specific mechanism in which opioids reduce the transmission of pain signals, and how opioid receptors cause specific effects such as hallucinations and dysphoria or respiratory depression. Click on the video link and watch the video to see if you can find the answers to the questions posed on the slides. You can fast forward to the 4-minute 29 seconds timestamp and end at 8 minutes 8 seconds. Once you're done watching the video lecture, you can come back here and check your answers. In regards to how opioids reduce the transmission of pain signals, opioids reduce the transmission of pain signals by decreasing the response of the postsynaptic neuron to any pain neurotransmitters, i.e., glutamate and substance P being released by the presynaptic neuron. In regards to how opioid receptors cause specific effects such as hallucinations, dysphoria, and respiratory depression, i.e., death, there are 3 types of opioid receptors on the postsynaptic neuron: mu, kappa, and delta receptors. These receptors reduce pain when they bind to opioids. However, each receptor is also associated with a particular side effect. Kappa receptors, for example, also produces hallucinations and dysphoria, including anxiety and restlessness, while it reduces pain signaling. Delta and mu receptors, on the other hand, also suppresses your body's ability to detect carbon dioxide levels while it reduces pain. If your body loses its ability to detect carbon dioxide levels, your body basically stops breathing because the apparent need to breathe is simply not there anymore. This is the reason why abusing opioids are so deadly. It is a fine line between euphoria, relaxation, and death. Let's discuss 2 classic symptoms that tend to occur when someone has reached high substance use levels. This applies to all the classes of drugs discussed so far, not just narcotics opioids. You know you have been ingesting a lot of the substances when you start developing a tolerance for that drug. What is tolerance? It is a state in which a higher dose is required to achieve the same effect. That means if you only needed 3 cans of beers to feel the effects of alcohol when you first started drinking but now need 5 cans of beers to feel the same effects, you have developed a tolerance towards alcohol. Another classic symptoms are withdrawal symptoms. These are symptoms that emerge when body readjusts to the loss of a substance that the body had adapted to due to regular exposure. In other words, you've been ingesting that drug for such a long time, your body has come to rely on that drug to simply resume normal functioning. Most people addicted to symptoms frequently describe this as the threshold between fun, I use this drug to feel good, and survival, I need this drug to basically have any semblance of normality in my life. This video describes one theory of how tolerance effects occur for opioid use. Take a minute to watch the video and come back to this slide to see if you can answer these questions. Check to see if the answer to your questions are the same as the answers provided here in this audio lecture. What happens soon after an opioid binds to an opioid receptor? The opioid receptor complex, i.e., combination of the opioid and opioid receptor, gets internalized into neuron. What happens to the receptor complex in the cell? There is delicate balance between the number of receptor complexes that get degraded and those that get reused in the cell membrane again. With prolonged use of opioids, more receptor complexes are getting degraded compared to those getting reused. This reduces the number of opioids receptors on the surface. Consequently, this individual ends up needing more opioids to suppress the pain transmission signal because there are only so many opioid receptors to work with on the surface. This explains the third question on why does the postsynaptic neuron need more opioids in the long run. Any drug can be fatal if a person takes enough of it, but taking drugs in combination with others can be much more dangerous than taking any one drug alone. Heath Ledger's tragic death illustrates the seductive risks of polysubstance use, such as the combination of illegal and prescriptive drugs. Abusing several substances at once may have a synergistic, detrimental effect that will make recovery all the more complicated and difficult, impossible to achieve. In some cases, drugs cause tissue damage directly. For example, chronic snorting of cocaine can damage nasal membranes. However, the negative effects of drugs on physical health are often indirect results of the drug's impact on behavior. For instance, people using stimulants often do not eat or sleep properly. Consequently, the rest of their health deteriorates precipitously due to the lack of nutrition and rest. And that wraps up our chapter on consciousness. I hope you've enjoyed this lecture and come to learn more about these fascinating topics pertaining to consciousness. Feel free to reach out to Dr. Chen if you do have questions, concerns about anything pertaining to this chapter. Remember that we have our first exam next Tuesday, which covers chapters 1, 2, 4, and 5. Remember to also complete the online form to make up our class today. Best wishes, and good luck studying.